We are now on to chapter 7. We spent a lot of time in this course learning more advanced techniques for calculating integrals on paper. And all of the integrals we've been looking at are for simple area integrals, area between a curve and the x-axis. But that is not the only thing that integration allows us to do. We can use integration to calculate other kinds of areas and even their higher dimensional analogs, like volumes, for example. So to illustrate this, let's look at two different curves at the same time. In the red, I have graphed f of x equals sine of x. And in the blue, I have graphed g of x equals cosine of x. And the question that I would like to pose is, how can we calculate the amount of area between the two different graphs? So here I have that area highlighted in green. Now, for certain parts of this area, maybe I could break this up and perform integrals in the usual way, right? Find the function that I'm graphing. Here I see that the sine function is on top. Use my antiderivative formula, and that'll tell me at least this sort of upper, well, it's not quite a triangle, but that upper trianguloid shape. That's not a technical term. Trianguloid is not a real math word. But that only gives me one piece, and it doesn't let me solve the rest of the area. I'd have to find other shapes that I can integrate, and that just seems like kind of a mess. We're going to learn a new formula that uses both curves at the same time. So just like an area integral, just a regular old area integral, has a Riemann sum, where, boy howdy, I wish I could add up a bunch of vertical lines to find that area. I can do that same trick with this shape. So here in purple, let me get rid of that green, it's making it hard to see. Here in purple, I have a line segment. And as I move my slider left and right, this line segment covers up the whole area between the two different curves, like so. It would be really great if I could add up the areas of all those line segments. But line segments don't have area. Let's put that aside. Let's use some imagination here. If I could add up all those line segments, I would need to have an area assigned to every single one. Well, how long is my line segment? It starts at f of x, and it goes all the way up to g of x. So this line segment is g of x minus f of x quantity. That's how many units long the line segment is. How wide is that line segment? Well, if it's an infinitesimal piece of the x-axis, that's going to be dx units wide. Okay, I'm not doing math here. I'm not doing calculus. This is how things would work in my perfect world. Instead, we got to go through Riemann sums and do limits and all that good stuff. But intuitively, I should see integral of g of x minus f of x dx, because I am intuitively adding up all of these different areas. So let's do this the formal way and see if our intuition is correct.